I hope my slides are visible. Hello, everyone.
Hi, sir.
Can you
Yes,
see?
please.
Okay, then that's good. All right, so as Dr. Icon introduced, my name is Evans and I'm part of the HCI lab. Yeah, so this morning I'll be taking you through how you can leverage ASR and TTS, basically speech technologies in your product building, right? Yeah, so in the next few minutes, I want to give you a map on how you can do that, how you can leverage these technologies effectively, right? So this won't be a lecture, and if you have any question whilst I'm presenting, you can raise your hand and then I'll call you to ask your question. Yeah, so I'll start by saying this. I'm sure you've with the subsequent modules that you've passed through, you've learned a lot. So this one is just to add to what you've learned, because what you'll be building might actually involve two or more of the modules you've gone through. So please pay particular attention to this. Don't be like, okay, my product is going to be based on this. You never know, you may need two or three. So make sure you pay attention to all of the modules. Yeah, so that I can use them effectively in your product building. Yeah, so I'll start by saying this. Regardless of the product that you build, you have to consider these three things. Particularly, I feel like these three things are the core things you have to focus on whilst you build your product for this hackathon. So you have to consider accessibility. You have to, that's the product that you are building. Is it easily accessible? Is it inclusive? And overall, can it scale? Is it scalable? So we'll look at all these three things, how you can do all those. Then, yeah, we'll bring the session to a close. Yeah, so automatic speech recognition and speech synthesis, right? That close the technology access gap for marginalized and underserved communities. Yeah, so you want to build a technology using these speech technologies, right? You want to build a product using these speech technologies for marginalized people and underserved communities in Ghana. So underserved communities, with respect to the West, we will say we are the underserved community. So you are basically building products for your setting, that's Ghana, the languages in Ghana. And also, whilst building that product, you have to include people who are marginalized. That's people who have some sort of disability. If you can do that, it's perfect. All right, so this session will cover why accessibility and language matter, where ASR and TTS may fail, right? Yes, but I'll go into details. So fine-tuning strategies and performance optimization, how you can integrate it into your product, right? The accessibility and language gap, that's how you can understand the problem. Then also how you can choose the right model for your use case, provided you want to use an ASR or TTS model. How can you choose the right model? And also how you can host and deploy or your models. Yeah, so why language and accessibility matter? So we want to look at this. Ghana there are roughly 80 languages in Ghana, right? And when we look at our current technologies in the market, most of them fail to um, integrate our languages in its framework. So what that means is people who can't speak English are taken out of um, this technology. They can't fully utilize it. So we want to bridge that gap for them to also feel inclusive, right? So that's where the inclusivity part comes in. But whilst you're also doing that, we know that the Ghana Statistical Service also says that amongst Ghanaians, right, there are about 8% of Ghana's population, right, have some sort of disability. So whilst you try to bridge the gap between technology and people who are more like handicapped and can't use technologies that are built in English, you also have to consider people who are disabled, right? So we want to design for every voice. That's through building ASR, right, and TTS. That works for atypical speech. When I say atypical speech, that's um you've gone through that disability module. So I'm talking about people who have some sort of speech impairment, right? So they can also leverage on these technologies. And also, like I've said, you want to create your technology with Ghanaian languages in mind. So right from the onset, before you lay down your blueprint on how to design the solution, you have to think of the Ghanaian languages. That's if you are using ASR and TTS. I mean, this hackathon is open-ended, so you may decide to approach your problem from a different angle. But if you want to use ASR and TTS in it, you have to start from the onset, consider Ghanaian languages, and also consider people who have some sort of speech impairment, right? So think of don't think of it as an afterthought, like after you are done designing the whole thing, then you are like, oh, maybe we can integrate this. That would give you a whole lot of problems. All right, so what is ASR and TTS? So when we talk about ASR, we are looking at automatic speech recognition, right? And what that means is you have a technology that is able to take speech, right? Do some processing and then output test. So ASR systems take some sort of sound, then bring out test. So for a system that utilizes and ASR technology, you know that you can speak to it and then it will write for you. The inverse is TTS, which is the text to speech. So with that technology, you give it test and then it can give you an audio, right? So they are two halves of the same conversation. So whilst that means if you can integrate ASR in your solution, it would be easy for you to also integrate what TTS in the solution. Yeah. So if it's possible for you to do the two, um, you should consider adding the two. All right. So any question up to this point? If anyone has a question, they can raise their hands and or you can unmute. Yeah, you can unmute and ask your question if you have any question. All right, since there is no one talking, I'll take it as it's clear up to this point. All right, so how do you leverage these models, right? When we look at the ASR and TTS space, there are a whole lot of models, but how do you pick the right ones? We have proprietary models, and we have open source models, right? So with our use case, you want to try an open source models. So these are some examples of the open source models that I've specifically selected that you can consider whilst building your solution. You don't want to have the hurdle of going through models and deciding on which one actually works for your use case. So we have the Whisper, which is owned by OpenAI. It's an open source model for building ASR technology. So if you want to leverage on ASR, you consider that. And we also have open source TTS models, mostly built by this group. Uh, it's a group and also it's a framework. So they are called Cookie TTS, right? They have a whole lot of TTS models. So if you are integrating TTS into your solution, that's where you'd want to look. And also Meta has a whole list of models for ASR. One is the Wave to Vec. So Open AI Whisper and then Wave to Vec are for ASR. Then the other three that you see are for TTS. That is, Meta also has a model for TTS, right? And then NVIDIA also has Nemo for TTS. That's if you want to host your model on device. It's good for that, but I don't think anyone has fine-tuned it on our use case. Yeah, so why I picked these models is because of our use case. There are lots of fine-tuned models out there based on this. We've done a whole lot of work at the lab too, so that you can have access to these models. But in case you want to uh, train your own model, you're also welcome to do that. But looking at the time, I wouldn't advise. The best way to go is either use our models or you fine tune with data out there. All right, so now that you've seen the models out there, how do you decide on which particular one to use, right? The model you pick should be perfect for your problem domain. So you don't want to choose a model that doesn't work for your use case. So we would look at some models that are good for some problem domains. That's so you look at so what I want to say is you look at what you want to solve, then you pick a model. There are a whole lot of models out there. If you see what you want to build, if you know that, which I'm sure all of you know, you can pick the perfect model, right? All right, so assuming you want to build something in agriculture, right? We have this company that is in agriculture, Farmerline. They have some models out there. You can consider that. You can consider some of their models, right? The lab has done some work with them too, so they're also model models that were built by both of us out there. They are good for agriculture and also no TTS. TT, Farmerline doesn't actually have a TTS. I meant to say so. The lab has a TTS model. Um, so the HCI lab TTS model, right? You can try that for your agriculture model. And also for health, there is a model out there, medical ASR. You can fine tune on it. Some people have tried fine tuning on it, so you can explore. So it's all about exploring, right? And then TTS to Quen has a model that is based on health, but then it's not in our local setting. So the point I'm trying to draw here is you don't want to choose a model that doesn't work for your use case, right? So I'm letting you know that okay, there are different models for different use cases. And then in education, right, if you want to build something in education, the lab has an ESR model built on Whisper, and also we have one built on Wave2Vec. You can try those, right? TTS too, the lab also has models on TTS built on VITs. You can try that too. And if you think you are doing an assistive, more like design, you want to build a product that works all around, the perfect models to consider are the labs models. That's the Whisper and Wave2Vec model, and also VITs models for TTS on various Akan languages. So out there, you find different models that you can leverage, but most of them are not in local languages. However, there are few out there in local languages built by some independent organizations and also the lab, right? So yeah, depend on your solution. You have to reach out to the lab for these models if you need them. All right. So now that you know these, you know how to pick your models, you know where to look at, you know the models to look at. You should also consider this. Now you have your models, right? Or maybe you are now selecting your models. Should you fine tune the pre-trained models, right? The models that you have. Should you pick a pre-trained model? That's a model that hasn't been modified or trained on any specific data. So fine-tuned models have been trained on some specific data. Pre-trained models are more like raw. They've been given the knowledge, but then they are not good at a specific thing, right? So if you have a pre-trained model, and there are lots of pre-trained models out there, should you fine-tune them or should you leave it like that? But you should also know fine-tuning will cost you data collection, compute, and time, right? You should factor that in your time frame for the hackathon. One, I would like to say this, you should know that fine-tuned models can also be fine-tuned, right? So if you find a fine-tuned model, and let's say you pick a fine-tuned model and you think, oh, it's it's not up to the level that I would want, you can also fine-tune it. All right. So before you fine-tune, you have to consider these factors. So one, you have little or no real target um, user audio, right? So the before you fine-tune, you have to make sure that okay, the model I'm working with, right? The model, that's the model you have, right? Was it trained with the target audio that I would want? If your answer is no, then you can fine tune. If your answer is no, that's okay. I want to work in agriculture. Was the model trained on agricultural data? No. Then you can fine tune, get some audio. Approximately 30 minutes will work if you have 30 minutes of aggregate data, or it can work for you depending on how you set your parameters or not and all that. So if your answer is no, you can fine tune, right? Then you also need you want to test your idea. That's, you need a working demo fast, right? To test the idea before investing further. You can fine tune. You tested the base model on real examples and the errors are clear. The base model, that's the pre-trained model that you have. You tested and you saw that, okay, it wasn't working. So you can fine tune it. It wasn't working on your use case. Maybe you tried. So in the case of ASR, you said something about school, maybe Akolani equals school or something, and then the model wasn't able to transcribe it like how you wanted. You can consider fine-tuning. But before you do all this, you have to first look at the first priority. That's your data collection. Do I have data? Right. So you can gather a small batch of real target audio. So once you've looked at these three points, you also have to consider this. Okay, the domain that I want to work in, can I get audio, at least 30 minutes of audio in that domain? If your answer is yes, you can go ahead and collect your data and then fine tune, right? Domain vocabulary or the language itself is missing from training data. Basically, same as point three. So you are missing a whole lot of words that should work for your domain in there. And then lastly, you have time in the schedule for at least one fine-tune plus evaluate cycle. So before you try all this, you have to draw a blueprint on how when you think, more like you have to run a simulation in your head on when you think this can when you think you can, the time period you think you can complete this. Maybe training, fine-tuning, I would give it like 8 hours or 5 hours max for your use case, right? So take that into consideration. So use that time, and also the evaluation cycle, making people test, because after you fine tune your model, you have to test and see if it works. So the rule of thumb, benchmark the pre-trained model on real examples first. So before you consider fine tuning, you have to benchmark the base model, the model that you have, on real examples first. That's the real examples here will be your particular use case. So try something on that and see um, if it works. If you don't do that, you are just making a guess and thinking it will work. You are not engineering your solution to the problem you want to solve. Yeah, this at this point, I would like you to. I feel like I'm talking too much. So, any questions from you? If you have any questions, you can unmute and ask. Is someone hearing me? Hello, guys. Are we there?
Yes, please.
No. Okay. All right. So,
Hello.
hello.
Yeah.
So I wanted to ask a question about, let's say, if you were thinking about if your field is in the health section, and as from the previous slide I saw that there wasn't that much models on that particular area. So if you were pre-training on an area where very little information, how much data would be required to, let's say, get a very good model in one of our local languages?
Okay, so if I get you, you are talking about pre-training, right? You want to train from scratch.
It depends.
Okay, so let me say this. If you want to pre-train from, you want to pre-train, you would need a lot of data. I would say the standard, right, is 10 hours plus. That's for pre-training. But then that's why I don't advise you do pre-training. But then if you want to fine-tune 30 minutes fine-tuning on an existing model, see, there are fine-tuned models in your local language out there, especially Akan. And even nowadays, I've been seeing a lot of other languages coming up, right? So you'd need 30 minutes plus data. I mean, 20 from 25 upwards isn't bad for this particular um, product you are building, right? So from 25 minutes up there, 25 minutes going, you are good to have a very, let's say, reasonable model. Yeah. So,
So
yeah, does that,
um,
all right,
does it
come
mean that,
listen.
let's say, I can take for example, I can take a general model like one from the HCI lab and then maybe fine tune it to a health related model?
Exactly, you can do that. Hmm. See, provided it's the same language, you have the same vocabularies in there, so it'll work. You have the same characters that the model is saying, the same, the model is learning from the same rhythm, same intonation, and all that. So it'll work. Is your question answered?
Yes, please.
All right. So yeah, you can take any fine-tuned model out there, provided you have data in your domain and fine-tune it, or even a pre-trained model that is in your language and fine-tune it. All right, let's move forward. All right, so you want to fine-tune, or you have fine-tuned and you want to improve your model, right? So this one more like answers your question, the question you asked. So you have a model out there, whether it's pre-trained or fine-tuned, you want to improve it. So first, you have to get data, right? Data in your domain. So if you want to solve something about impaired speech, get data on impaired speech, right? If it's accented speech, you get data on that. Maybe you want to have paging um, model, something. Yeah. So data in the domain you want to solve, right? You make sure you clean and label. So that's like audio and text pairing. You make sure that's the labeling. You make sure your audios match with their respective text in your data, right? Then you do some sort of augmentation depending on, so There's actually a generalized way of improving models in speed with speed technologies. So it works for both ASR and TTS. It can do some sort of augmentation, can vary speed, pitch, add noise, right? Do You can do a whole lot. So you have to try different scenarios and see what works. So after you have your data augmented and all that, and you can decide to take the augmentation process out. So 3 is optional. You can either decide to augment or not augment, but then you have to decide on which one is giving you the best output. Then you fine tune. So when you have your data ready, you can fine tune on the base model that you have. That's the model you have. You train it with it, right? After training, you evaluate. So evaluation for both technologies are different. With ASR, you want to look at your weather rates or character error rates, and then with TTS, you want to look at your mean opinion score. That's most. But then we all know that we want to build something for the market. So I would advise that you don't focus on these theoretical parameters, the weather rate and then the most. That's the evaluation metrics for each of the respective models. You want to base your evaluation on real human testing, right? People actually testing the model you've built. So you can theoretically your model may be performing well, but then when a human talks to it, then it's somersaulting and turning heads and all that. See that the model is getting confused. And yeah. All right, so a few hours of fine-tuning beats training from scratch, right? And also it fits your timeline. And so with this, I'd say the best approach, I'm saying it again, the best approach is fine-tune. Don't try to train from scratch. However, if you think you can do it, I mean, some people have superhuman abilities. So if you think you can do it, you can do it. All right. Now, since some of you may be new to these fields, ASR and TTS, there may be some things that you may face that you think, oh, my model is not good enough. I have to solve this. I have to do this. I have to check this out. I want to let you know that there are inherent problems that have not been solved out there that I wouldn't say you can't solve. You can't solve it. You can't solve it by looking at the time. If you face these problems, you shouldn't um, be low in spirits or demotivated, right? So with ASR, it, there could be limited training data, right? And also the atypical and this archaic speech underrepresented. That is, if you want to solve speech impairment and all that, you may not have enough data out there. Maybe you may decide to um, collect your own data. I don't know how that is viable, but yeah, if you decide, you should know that there is this problem where you may not have enough data. So your model may not generalize like you would want to. Maybe you would work for one person and not work for the other. If you face such a problem, I think it's okay. If it's working for one person, it's okay. and also accent and dialect variation, right? So you may train your model for Asante Tree and someone will speak Akiapim Tree and your model will be confused. It's normal. It's not something you should take to heart, right? And then code switching too is a problem. So code switching is where, in our languages, most of the time when we are speaking, we mix it with English, especially fancies, right? So you will say something, you'll be saying chia, then you chip in some English. So in such cases, the model may or may not be confused about the English word you use. So an example, you say, ebia, I don't know, I'm not finding a good example, but this example in my head, it's not something people say, but let me see. Okay, so something like, okay, Kofi, Kosensu Nafabra, inside, right? So you see, you are speaking Chi, then you say inside. I mean, it's normal in our utterances, our daily lives. We end up using sentences like that. So things like that may confuse the model, or the model may not perform well on that. It's normal. And then some data have no poor noise, right? And due to poor microphones and all that, like they have very bad noise in it. Some of the data out there. So you want to consider that when building your ASR model. So if you have noise in your data, you want to look at cleaning those noise through augmenting your sound, right? Your data, so that you can take away the noise. All right. And also pronunciation ambiguity. That's tonal languages and all that, I can, some people say, someone will say miyam and someone will say miyim. So maybe the data that you used to train, the person said miyim, and then someone is saying miyam, and the model is getting turning heads and all that, like getting confused. It's normal. The the goal is for you to capture what the person is trying to say. So if you can do that, it's fine, right? And then, yeah, domain specific and out of vocabulary words. We've talked about this. So if you have a model and then it's a general model, but then you want to say something about health. So let's say a TTS model that was trained on general data and you want to say, you want to type, okay, I have malaria, right? Well, in chi, you say maybe chi crown malaria, I kind of say, yeah, may war a tree di yare, right? Be bisa, then you you see that you type that, and then for a TTS model, the model will get may war, then it will get to the 3D, then it will blank, or maybe you pronounce it in a very funny way, then pronounce the yare, right? It's normal. So that's why it's normal, but it's not normal for your use case. That's why I'm saying you have to look at the problem you are solving and make sure you pick a model that works for it, right? Yeah, and TTS, I mean, the problems are like same for both. It's the same thing. Few high local lang voices, right? So for TTS, it's highly based on speaker, highly based on the speakers that are more like saying the speakers that were used to train the model, or the speakers that recorded the data, right? So because it's highly based on speakers, you you may have one thing, you may have a sentence, a different speaker will pronounce it better than the, the other. So you want to look at a speaker that gives you more clarity in your work, right? So make sure you try different speakers in case it's available for you to test different speakers. Make sure you try the one that works for your use case. Yeah, pronunciation and tonal errors. Explain that in the ASR. It also happens in TTS, right? The model can pronounce some words that it hasn't seen in a funny way, right? Then flat prosody or natural rhythm. So how the model will read the speech you generated. You're expecting the model to give you an output that people can really relate to, that will feel like, oh, someone is talking to them, not like they are having a conversation with a robot. See, most models out there, when you listen to the sound, feels like you are talking to a robot, but you are trying to come up with a solution for people. So the speech you end up generating should feel human, right? But then I'm saying this because it can be one of the problems you face. Your The generated speech may be flat, as in it has no rhythms. I say it's just reading it raw. See, when we are talking, we have some stresses. There are some points you feel like you go high, you go down, and all that. That's natural for humans, but for models, takes time to do. So you want to focus on that to make sure you eliminate the flatness to the best of the model's ability. You can't take everything away, so you may have a little problem there, but make sure it's not very robotic. Yeah, and then models have a hard time reading numbers, right? Abbreviations, and then code mix test. And also currently TTS models we have there, they don't catch expressiveness and then emotions. They won't know if someone is sad and all that. So if you want to come up with a solution that contains this aspect, maybe contains emotional range, expressiveness, and all that, you have to make sure you have a data that does that accordingly. Yeah, voice quality and licensing constraints. I mean, yeah, I've also said there's some voice are clearer than others, and also, and whilst you are training your model or collecting data, should you decide to collect data and fine-tune the model, you have to make sure the person agrees, right, to uh, his voice being used, right? And also there are some models out there that you can't make them commercial. So if you are developing a solution that you want to make it commercial in the end, you have to look at the license of the model you are using. Maybe it's not allowed to, it's just for research purposes, or yeah, research training, building some um, examples inside. You are not supposed to commercialize it. So take all those into consideration. All right, so we want to look at this particular side. If you want to design for speech impairment, or I should say people with some sort of disability. I mean, the goal of this hackathon, I already said it, to bridge the gap and all that. I'm sure other modules you learned how to design for other disabilities, right? So I know as you have computer vision as part of the mentorship modules. I mean, that would be helpful for people who want to design something for um, sign language and all that. Yeah. So with this one, we are looking at speech. So I've already talked about, if you want to look at some sort of speech impairment, you have to make sure you have data on speech impairments. The model you are using was trained with data of speech impaired people, right? And also, the best way to, or the easiest way to get the most efficient result is to personalize per speaker. You trained your model on one speaker's problem, right? So let's say Kojo stammers, you train your model with Kojo's voice so that your model can actually know the nuances in Kojo's voice. And that's if you want to get I mean, training on different people with speech impairment works. It works, but then it's not efficient, effective as training on personalizing to single speakers, right? And then after that, you test with real users, right? So always, when it comes to these ones, you're designing for people. So always test with real users. You don't want to create a model or design a model. After training, then you test with the test data you use to test, or the train data you use to train. You want to test with the actual humans. All right, so I'll pause here, then invite questions. Hello, guys. Are we there?
I would say I'm here. So please, I have one question. So
All right.
about training your models, and then the models you shared, especially about the DIC one, the one internally from the lab. Is it possible
Yeah.
to train your model and data with it, and then still train it with other models? Is it still allowed, or is it going to create some confusion or stuff?
Is it possible to?
To train like your the model that we are going to create that won't start from scratch. Let's say we are
Okay.
using the internal DCIE how do you call it model, the ones you shared, the ones that
Yeah.
included Farmerline or yeah.
Yeah.
So let's say I want to use that, and then I train it with it, and then I can be able to use, let's say, Claude or another thing to be able to enhance it also, or that will not be great.
Okay. So if I get your question, that I'm trying to. Are you asking if you can use that? You can use Claude to enhance those models.
Yes, please. Like, yeah, be able to use Claude to enhance it.
Claude, as in Claude AI.
Yes.
Okay. So yes and no. So why do I say yes? Yes, because if you have that model, you can choose to fine tune it, and then Claude will help you with your code, right? Help you write the code on how to fine tune it. So that's a yes. You can use Claude to, or any AI to help you fine tune it. No, a big no, because Claude can't enhance the model on its own. Claude can't actually do fine tuning, right? Do you get it? You have to
Okay,
go
sir.
to, yeah, because Claude can't collect data for you. You have to go through the data collection process. Claude may give you pointers on how to collect data, pointers on how to augment your data, right? But they can't augment for you unless maybe you manage to design an agentic AI that can do all that. You design an agentic AI that can collect. Even with that, it still needs real humans for the data collection. So yeah, Claude doesn't, it helps, but in the grand scheme of things, it doesn't help you. No.
Okay, sir.
Yeah. All
Because we were
right.
thinking of a way where we are going to use like the RAG architecture systems, and then we have quite some data on route intelligence systems where we want to be able to automate it with into speech and other things. So we were thinking that since we have the RAG system that has it's already embedded with Olama, and then we are using Claude as just the brain to answer some of most of the questions. So we're thinking of maybe you can connect it to the models and then be able to still have that architecture sort of.
Okay. When you're talking about connecting, yes, you can do that. But then if it's connecting, interfacing your um Claude and then any speech model, yeah, that works. You can do that. But then does Claude understand? I mean, are you doing it in English? What language are you doing? If it's English, that makes the work easy for Claude. But then does it solve the problem we are trying to solve here? If it's in our local language, you have to ask yourself, does Claude understand the local language? If Claude understands the local language, you are good to go. But if not, it won't help that much. Unless maybe you are doing some sort of machine translation in between somewhere where you actually convert to English and then Claude understands what is going on, then gives the output back, and then you translate to the particular language you want. See, are you clear on that?
Yes, sir. Thank you very much.
You're welcome. Is your question fully answered?
Yes, please, sir. Yes, please.
Hey, today I'm saying, oh, all right. So,
Please also
yeah,
have
any more questions?
please I have a question.
All right.
You mentioned noise being an issue when you are training a model, but what if maybe let's say you're in an environment where it's mostly noisy and maybe you would need the noise to train the model to, and maybe if the data is also too clean, the model will struggle in areas that are noisy.
So if I get you, the model will be used in an environment that is noisy.
If let's say the sound I'll be coming will be noisy.
Okay, so you are trying to say that your use case, right? I'm trying to get whether you mean during the data collection, you have a noisy data, or the environment you'll be using the model will be noisy, so you need the noisy data. Which one are you trying to?
And the environment you use it in will be noisy.
Will be noisy. So well, a little bit of noise doesn't hurt most models, So sometimes we even intentionally throw some noise in there, like you said, for the model to actually know um, like the noise that we have in the background and all that. So no, it doesn't hurt the model to have a little noise in there. So like if you want without noise, which mostly that's what we do. I mean, the normal case we train without noise. I mean, training without noise doesn't necessarily mean it's devoid of all noise. I mean, you can't take away noise completely. So yeah, if you'll be using it in an environment where there is noise, you need to introduce that little bit of noise um, in the data during your data collection. However, you want to consider the noise not overwhelming the actual speaker, right? So it's not like you can't train if you have noise in there. You can train if you have noise in there. Sometimes we even intentionally introduce noise to make the model work in the cases, some of the cases you mentioned, right? Yeah, so is your question answered?
Yes, please. My question has been
All right.
answered.
All right. Any other question?
Yeah, hello, good morning.
Good morning.
Yeah, so my question is, with the models you showed us, the ATI Whisper with to the BITS, are they publicly available on any platform that we can use in our work, or we have to request this from the lab?
Okay, so the Whisper and NTTS are available on Hugging Face. The lab has a Hugging Face page, so yeah, it's available on Hugging Face. So
Yeah, so
you can check it
check
out on
the
DCS.
sorry,
Have it. You can pull it from DCS HCI Hugging Face.
yeah, I checked the Hugging Face repository and it's currently a single model that's the account maternal health MMS 1B. That's the only
Oh,
model. Yeah.
okay. So I think you you have a channel through which you can reach the facilitators, right?
Yeah, unless the recommended emails.
Okay, so you send an email and then um, you'll be provided with the resource that you
Okay.
need, Yeah.
Okay. Yeah. And my second question was around the um personalized per speaker. So I wanted to understand what that means specifically. Does that mean that training across like the different etiologies you have in your per speech data sets, and then like having a general model that's like exposed to all the different data sets, and then having a single model exposed to a single etiology, like a single disability in the data, because in your
Yeah.
data sets you have separate conditions like clefts, stuttering, stammering, stroke, stuff like
Yeah.
that. So I wanted to understand what this statement specifically means. Personalized per
Okay.
speaker.
Okay. So this what I mean. So in our models, right, for speech impairment, we have one where we've trained on all the etiologies, right? And then we have individual models for different etiologies. Do you get it? So what I'm trying to say is, assuming you want to create for stammering, it would be best. I'm not saying you can't use the general one, the one we've trained on all etiologies, but it would be best to use the model that was trained on stammering, right? And then once you've done that, it would also be best to actually come up with a solution where mostly for on-device products, you can come up with a solution where the person that is actually going to use the model or the product will have the chance to send in their voice for the model to learn from their voice, right? So anytime they speak, it's like the model has seen their voice, so it understands it better. So you don't
So
want a,
okay, can go ahead.
you don't want a situation where, see, even though you have let's say two people may have the same problem, stammering, but then they have different voice. The fact that they have the same problem doesn't mean their voice comes with the same tone and rhythm and all that. So you want to consider that, right? So I'm saying that if you want the best, I mean, our results have shown that if you want the best outcome, you personalize to people, right?
Okay. So
Yeah, you
essentially,
can.
if I understand you, um, it's like having a model trained from a certain condition, and then during the testing, no, let me say, deploying it to a specific user, you let the user have some adaptation of the model to suit them because the model has to at least see the patterns in their voice to be able to understand their voice clearly as compared to having a general model that has been trained on like everything. So my follow-up is that okay, so the single model trained on a different, so would you suggest like okay, so having a model that has been trained on the different impairments and then the single one, which one do you think in your work, which one worked well for the personalization? Was it a general one or the single one that was trained on a specific condition?
All right. So I would go for, I mean, I haven't, or I'd say we haven't exhausted all the possibilities out there, but as at this moment that I'm talking, I would go for the personalized one, the single person one, right? That's what I would go for. But, oh, I mean, single etiology one, right? That's what I'll go for. But I don't know your use case, right? And then the more the merrier. So it's like if you are solving more problems, it makes your product more scalable. We are not saying you should have a perfect model. So yeah, whilst I'm saying the single etiology works best in, it doesn't mean the general one doesn't work. It works. So you do also consider the solution you are coming up with. right?
Thank you.
You're welcome. Any other question? If not, yeah, we move forward. Yeah, I think we are coming to a close, fast approaching the end. All right. So now you know all about models. So we want to talk about where you can host your models, right? I mean, you've come up with a model or you've gotten a model. Now, how do you deal with it? Because you have to host it. And there are different options. So you have the GPU cloud, right? You have the CPU cloud. You have on device, right? And then you have model platforms too. So GPU clouds, that's the best. It can host large models, and also if your traffic is high, a lot of people are making requests to the model. It works faster, right? So examples of these platforms, we have AWS, RAN pod, Modal. I think the cheapest is RAN pod, followed by Modal, right? So you want to look at these platforms if you want to host with on a platform with GPU. If you think your model is that lightweight and you want to host on CPU, right? You can look at Render. The developers, most of you have used Render and also Railway. So you can look at it. You can look at those platforms, right? But you should know that if you are hosting on a CPU, then you are trading off latency, right? Means you have um, high latency. Your request will be slow and all that. And then on device. So for on device, it's very fast, and also you can use it offline. So it's like you are hosting the model on um, a phone or a particular device, any technology. So that's the person is using. You are hosting the model on it. And then there are some runtimes that you can.
I'm going to stop using Braille. Yeah,
Who who
every
is
day
who is whose mic is on? Okay. Yeah, so on device you have some runtimes that you can use, or frameworks that you can. Onyx and Core ML are there. I think there TensorFlow also has one, TensorFlow Lite. There are a couple out there. And then you have model platforms. But these ones, they are just for demos. I mean, demos, and more like you can't host because it's timed, so you can't host it for a longer period of time. Hugging Face um, has that platform, and I think there is this platform, if I Ocean something, I've forgotten the name, but yeah, it's also for demos. Yeah, so these are platforms you can consider for hosting your models, depending on what you want, right? And Sikasem. All right, so yeah, but for now, since you are just in the prototyping stage, I would then endeavor you to host it on your laptop. Use your laptop as a server, right? If you are in an institution and the institution provides um, machines for you to host models, maybe you have some HPCs that you can host, and you can consider that too. You have access to that and host your models there, right? Yeah, so if you host it on your server, you use if you use your machine as a server, you can wrap it in an API by using fast API, or create endpoints where people can, hit and then make requests to your model. Then you can use ngrok to deploy, make people have access to it and all that. Yeah, but then you know that the moment your machine goes off, that's the disadvantage. The moment the machine goes off, your system is down, right? All right. So this way works best for during testing whilst you are testing and all that. Don't go and bother yourself with AWS and Modal and all those platforms. Less before your money finishes before you get to the final. All right, so how to decrease latency in your app or the model. So if you have a model and you think sometimes the platform that you're hosting your model on maybe slower due to the weight of your model and all that. So you want to consider all these things. Even when you are fine-tuning a model, you have to consider all these things. How big is my model? Can it fit on this particular GPU? If it's this big, can I use this budget GPU? If it's this big, if it's this small, can I use this budget CPU? So you should make sure you consider your budget, whilst building the model too. You wouldn't want to build a very good model and then now you can't host it because the hosting platform says quote some amount you can't afford. So if that happens, you want to shrink your model. That's by you can quantize it, right? Reduce, more like reducing the bits or maybe the decimals that can follow it. That's reducing weight basically. So you can use 8 bits, you can use 16 bits, 32 bits, and so forth. The higher you go, the more you can represent more weights or more numbers. So you want to reduce it. If even 4 bits is available, you can try, but mostly 8 bits is the standard. You can try and see. So reducing your weight helps. And also you want to try with base models. So if you are fine tuning, let's say ASR, you want to try with a version like Whisper Tiny or Whisper Base, right? Or Whisper Small. Don't go like you start and then you go Whisper Large. So start small and then you make sure you move your inference closer to. So prefer on-device or regional hosting, right, over a single distance server for latency sensitivity. We've talked about latency, so you want to make sure when someone makes a request to your system, it's fast. The moment someone makes a request, output comes within some seconds or minutes, right? Minutes is too long. So within some seconds. So you wouldn't want someone making a request and then waiting for minutes before they get. If that happens, they will lose interest in the technology. I mean, better they use tools and access them down to use your supposed advanced technologies that gives them, headache. And in designing your APIs and all that, make sure you go asynchronous, make sure your calls are asynchronous so that whilst the requests are happening, the software could be doing something else. Maybe it's rendering a screen or something. You don't want your request to freeze any other thing that happens on your software. Well, and also with TTS or ASR, make sure you stream. You can stream your output to make sure it's fast, right? So what that means is your output is coming in chunks. You don't want to just bring out the output, the whole output. You don't want to give the person the whole output, more like the final output out at once. If that happens, it takes time, because let's say the whole thing may be taking 30 seconds to process. So you want to be giving the person, okay, when the first 10 seconds finish, you give it to the person. The second 10 seconds, you give it to the person. You don't want to process the whole 30 seconds and serve it to the person. Make sure you have an architecture where the person gets the information in chunks. And also you can cache common cases, right? So there are some sentences that you think are very predominant, people say it often, or some words people say. You can cache them so that the moment they pass through the model doesn't do any processing. It just serves it, fetches it from the cache memory, and serves it to the user. All right. I think I've talked about the latency budget and all that. All right, so resources and then next steps. So models, we've mentioned Whisper, Wave to Vec, and Meta MMS. I mean, Meta has a lot. That's where Wave to Vec comes from. Then Cookie for TTS, you have Cookie. Then NVIDIA Nemo. NVIDIA Nemo is good for on device, if you want to do something on device. Then where you can host, we have Modal, Ramport, Replicate AI, Hugging Face for your use case, not very scalable, right? And then data. So data, we have data at the last WAHO data, UGSP data, right? And yeah, we'll give you access to that to train your model. And then if it's TTS data too, yeah. I mean, if it's local data you want to speak to the lab, right? And then you can learn something from Google has a project called Project Euphonia. It has a lot of info on how to develop models or products for speech impaired people. Yeah, so you can learn something from that too. I don't think their data is open source, but looking through that will go a long way to help you. All right, so evaluation. So evaluation, I've already mentioned it. ASR, we have the word error rate, and then character error rate, so which is the where and then the cell. Then we have the mean opinion score, which is most for TTS, right? But then the golden evaluation technique is for real people to test. All right, so in your building, you want to avoid these things, right? So testing only with your own clear voice, never a target user. We've talked about this. You don't do that. You are designing for people, so people should come first, right? Assuming cloud API latency is fine for a real-time conversation. So that's where the methods to reduce latency comes in, right? So sometimes making API requests, you think you have the best cloud platform, so if it's slow, it's normal. No, you make sure you work on the model. If you have to reduce the weight, reduce it, and make sure your model um, actually works best for people. And also, don't ignore code switching between English languages and local languages. So make sure you take that into consideration, because people mix English with their local language. So as much as you can, try and consider that. I'm not saying you have to catch all the um, conditions where people use that in your product, or you have to meet everything they do, And then no offline or low connectivity fallback for rural areas or low data users. Since we are developing for us easy accessibility, right? And also people that are disadvantaged, it will be prudent to make sure your solution works without connectivity. Well, I'm not saying it's a strict requirement. If you can do it, especially if you are going the on-device way, this becomes easier, right? If you can do it, you try. All right, and then don't skip consent and privacy review for recorded speech data. If by any chance you are recording data from people, let them know, right, what you are using it for. Make sure it is formal. You don't want to commercialize someone's voice and be profiting from it when they know nothing about it. All right, so on that note, this brings us to the end of this session. I'm glad for the chance to meet you guys, and answer your questions. It's been very, engaging. Yeah, I think so. And you guys have also been asking questions, so yeah, I've enjoyed every minute and bit of it. So since I've exhausted the slides, I would like you to bring in questions, contributions. Yeah, anything you have in mind. Can you hear me?
Say,
Yeah, and also
I
you
don't
can
have any
reach me.
question.
Okay, you can reach me via my email, if you